So what we're going to do now is we're going to now introduce the next huge idea, or we're going to begin to introduce the next huge idea of calculus, which is called the integral. And we're going to start out with this idea of the antiderivative, which is kind of a big basic idea inside of integration and the integral. Okay, so what we'll start out with is a definition. A function big f of x is said to be an antiderivative of little f of x if big F prime of x equals little f of x. Right? So basically the idea here is that f of x, right, is going to be this antiderivative for f of x, right? If we take the derivative of f, we get little f. Okay? So like we'll give you an example. Say for example I use f of x equals cosine x. Okay? Well, if I think about this, big F of x, right? We want f prime of x to equal cosine x. What is the function that actually does that? Well, the function that actually does that is sine x, right? So we get big F of x is going to equal sine x. That's an antiderivative. That's an example of an antiderivative for little f of x. Because if I take f prime of x, that's just going to equal cosine x, right? Which is equal to f of x, little f. All right? So that's the basic idea. We're going to kind of go backwards and forwards. Let's take a look at another example. Let's say, for example, we have little f of x equals x squared. Okay? And we want to find big F of x. Okay? So that means that this is going to be f prime of x. So the question is, what's the derivative? Okay, what function has a derivative equal to x squared? Okay? And so if I kind of think through this and work through it, what I'm going to get is I'm going to get that big f of x is going to equal, well, I know it's going to be x cubed, because when I take the derivative of x cubed, I'm going to get an x squared. And in addition to that, I'm going to have to divide through by 3. Okay? X cubed over 3. And that's because if I take f prime of x, right, which is going to be d dx of x cubed over 3, what I'm going to get is I'm going to get 3x squared divided by 3, which just ends up equaling x squared. Okay, so basically this division right here is accounting for the fact that we did multiplication when we actually took the derivative. Okay, so when we took the derivative, we did multiplication. So when we take the antiderivative, we're going to be doing division. Okay, and in fact, that's going to be a really important part. This whole idea that we're going to be reversing a process. Okay, so the antiderivative for x squared is x cubed over 3. Okay, let's try that again. Let's find an antiderivative, and this time let's take f of x, okay, equals 1 over x. Excuse me, little f of x is equal to 1 over x. Well, what I know is I know that the derivative of natural log of x is 1 over x. So that tells me that big F of x is equal to the natural log of x, okay? Because that's the derivative. Cool, right? So what we're going to see, or what you're going to see, and inside of your book, there's a table of antiderivatives. And what you really want to do is you look at the table of antiderivatives, but this means really know your derivative. Because by knowing your derivatives, you can figure out your antiderivatives. Or the patterns for antiderivatives become really a lot more natural, right? Say, for example, when we look at the power rule said, okay, when I take the derivative, okay, I'm going to subtract 1 from the power and then multiply by my previous power. Well, to do an antiderivative, I'm going to add 1 to the power and then I'm going to divide by my new power. Okay, it's like unfolding or unwrapping the previous operation. So this begs the question next: Is big F of x equal to x cubed over 3 the only antiderivative for little f of x equal x squared? And the answer is actually no, it's not. Okay, because while we know that f prime of x equal to is going to be equal to 3x squared over 3, which equals x squared, right? That's true. Watch this. If I take f of x equal to x cubed over 3, right, plus 7, then f prime of x is also going to equal 3x squared over 3, right? And then the 7 goes away because the derivative of 7 is a 0, okay? So this becomes just plus a 0, which is equal to just x squared. So again, right, that constant, right, the constant goes away. And if you think about this, this is always what's going to happen, right? With any derivative, if you take the derivative, all of its constants go away, they become zeros. And so consequently, we lose information from when we take the derivative. Okay, so we're going to lose information when we take the derivative. And what that means for us is that when we take the antiderivative, we're going to have to account for the fact that we lost that information. Okay, so when we talk about a generalized antiderivative, we're going to have to add on that constant. So what we're looking at here is if f has the antiderivative big F of x, okay, then the general antiderivative for f is big F of x plus c for some constant c, right? And we're going to need a method for us to figure out what that constant c is. And that constant c, we find the constant c by using initial conditions. Okay? And we talked a little bit about differential equations before. Well, a differential equation is essentially a derivative, f, okay, combined with an initial condition that will allow us to get back the entirety of the antiderivative. Give us back big F of x plus c. So let's take this example. We'll have little f of x equals 3x squared plus 7x minus 4. And we'll have this initial condition, right? F of 0 equals to 5. Now, sometimes you'll get something like f of 1 equals something else, or, you know, depending upon the function, right? Sometimes it makes a lot more sense to start at f of 1, right, versus starting at f of 0. But for this function, it makes sense to start at f of 0, right? So we're going to find the antiderivative. And in this case, we're not going to get a general antiderivative. What we're going to get is a very specific one. Okay, so we'll first start with f of x. And so our big F of x is going to equal, so we'll take 3x squared. We'll do that one first. So that's going to give me 3x cubed, and we'll divide by 3. 3x cubed divided by 3 plus 7x, now squared, divided by 2. Minus, and then this will be 4x, and that's because 4 is a constant, right? So negative 4 is the derivative of negative 4x. And then this will be plus c. Okay, so take a look that we're just utilizing, we're kind of doing the backwards of the derivative. Okay, we added 1 to the power and then divided by that number. We added 1 to the power, divided, and then for the constant, right? Okay, what we did was we just added an x onto the constant. Now what I'm going to do is I'm going to take f of 0 equals 5. So that means, or excuse me, big F of 0, it should be, equals 5. So f of 0 equals 3 times 0 cubed over 3 plus 7 times 0 squared over 2 minus 4 times 0 plus c is going to equal 5. And what you notice is that these terms go away, the first 3 terms go away, and so we end up with c equals 5 as our constant. So that means big F of x is going to equal x cubed, right? Because we can just factor those out. X cubed plus 7 halves x squared minus 4x plus 5. Okay, and that is the antiderivative of f of x, or little f of x, excuse me. Let's take a look at another example. Let's suppose that let's use f of x equals cosine x, okay, plus, and let's take cosine x plus 3x squared, okay? So we got cosine x plus, and not 3x squared, let's just use 4x cubed. All right, and we're going to say that big F of 0 is going to equal 0. How about that? We'll make big F of 0 equal to 0. And so now let's find the antiderivative. So the antiderivative of cosine x is going to equal sine x. So this is going to be sine x plus, and then we'll use the power rule. We'll go up by 1. So it's going to be 4x to the 4th divided by 4. And then we'll just plus c. And then we'll just simplify. This will equal sine x plus x to the 4th plus c. And now I've just got to plug in 0. So f of 0 is going to equal sine of 0 plus 0 to the 4th plus c. And that then is going to mean that which equals 0. And that's then going to give me that c equals 0. So in this case, the antiderivative for this particular equation, this particular differential equation, in fact, is going to equal sine x plus, notice that those will factor out, x to the 4th plus 0. So just sine x plus x to the 4th. All right, so that's how antiderivatives work. Basically, what they're going to do is we're going to learn how to reverse the process of taking the derivative. Okay. Now, this is going to take some practice, right? So I highly recommend that you go in, you practice, practice, practice. And if you don't have your derivatives mastered, you need to go master your derivatives. Okay. So that completes the lesson. I'll see you next time.